1, Chapter 1, Lesson 4, Retic Series. Last piece of arithmetic, so we switch to geometric. So tomorrow we'll start geometric for you guys. When the terms of Retic sequence are added, the result is known as a Retic series. So we're used to the pattern of 3, 5, 7, 9, 11. That's just a sequence of +2. A Retic series is the same pattern, but you're essentially adding the pattern. That's the only thing that changes. Okay, how this helps us is if we're asking for travel. So if it travels 3 miles, then 5 miles, and 7 miles, how many miles total traveled? Then you would add the pattern to figure out a total traveled. So if you're wondering how it comes into play of meaning something, that's how. Okay, so the symbol S sub n is used to represent sum in terms of Retic sequence. So example, S sub 5, that means 35. Okay, and so I'll show you what that means. 3 plus 5 is 8, plus 7 is 15, plus 9 is 24, and then we have 11 is 35. So just adding all those up is 35. That's where the 35 comes from. So they do a little bit of investigation here, kind of show you how the pattern was developed. Okay, so a little bit slow starting, and then we'll get to some examples where you'll feel a little bit better. Okay. Adding the pattern. Okay, so, you know, maybe interesting enough or maybe not interesting to you, but actually to report on Carl Gauss when I was in college for my math major, so he's a real person. Okay, so when Carl was about 10 years old, he placed Master Butner's arithmetic class. Master Butner gave his class long arithmetic problems to keep them quiet for a long time. On one particular day, Master Butner asked his whole class all the sum of all the numbers 1 to 100. So he's trying to get all his kids to go 1 plus 2, 3 plus 3, 6, and keep doing that, and which he's hoping to take a long time. While all the students began to work madly on the assignment, Carl laid out a slate on the desk and informed Master Butner he was finished. Master Butner asked Carl what his answer was, and to his astonishment, he was correct with the answer of 50-50. So how did he do that in a quick manner? Well, we can use our sequences and series to help us with that. So here we apply the method similar to what he did. He had S of 100 would be just adding them all, right? But we know if we went S of 100 and we went backwards to 1, that's the same thing. Does that make sense? So if I did that, do you see what's every combination here? 101. So it's 101. So we can simply do 101 all the way out, right? Just forever. Whatever. We know it keeps going and it finishes with 101. Well, how many 101s is that? 100 of them. So you go 100 times 101 divided by 2 is how we got the answer so quickly. So essentially, replicating the pattern as two patterns, okay, and overlapping them to a similar number. Now, obviously, that's a very smart mathematician approach, but that's kind of where our formula is going to come from that we're going to use. You don't have to memorize the formula. You give them the formulas in the spot I showed you in the back of the book. And so when you do this calculation here, that's where the 50 comes from for S of 100. Again, when you see S, that means series. Okay, S sub n. Okay, so S of 100 in this case is 50-50. Okay. All right. So this just is all that was is to show you where the formula came from. Okay, so formulas for some of arithmetic sequence. Okay, arithmetic sequence of n terms. First term is A. We need A and D and N still to do it. Okay, this is kind of just a long. This is kind of just writing it out. I'm not going to read you through this because it's probably a little bit exhausting to focus on. There's a lot of stuff going on here. But they're just showing you that A plus D, A plus 2D, which we know that pattern. Okay, or conversely, the other way around, A plus N minus 1D, so distributing all the things we've done for our patterns. So they're showing you how they doubled it and how the formula comes about. But again, this is kind of just what we'll use for now. Simply, that's the formula. Okay, it's N times 2A plus N minus 1D all over 2. Okay, and that's when you have A and N and D. Okay, however, when the common difference of the series is not known, there's another formula you can use. So if you don't know D, then you can use N and T sub n and A. So this one you can write a note in. This is for when you don't have the common difference. This is for when you do have the common difference. Okay, both of those formulas again are on your sheet. And now let's do a few examples of it. All right, so let's go ahead and just apply it here. Okay, so determine the first and the 14th terms. Sorry, the first 14 terms, not first and. First 14 terms of Retic Series 9, 15, and 21. So it wants a sum of 14 terms in that pattern. So you want to get in the habit of identifying A, D, and N. Here's what you want to identify. What is A? 9. What is D? Good. And what is N? 14. You have everything you need to use the basic formula. It's not always going to be that simple. You have to do a little bit of work to find this stuff sometimes. Okay, but in this case it is. So I'll write the formula one more time here, and then we'll use it. But I won't write it up there every time. I'm just going to save us some time here. And to be honest, I don't memorize these formulas either. I just know how to use them. So don't feel like you need to memorize them. So we're doing S of 14 is 14 times, the 14 there, times 2 times 9 plus 14 minus 1, I'll just write 13 with a common difference of 6 all over 2. Now you can just calculate that if you'd like, or you can simplify it, whatever you're more comfortable with. Like 14 over 2 is just 7, so I can write 7 times 18 plus 6 times 13, 60, 78. Okay, and when you calculate that, you're going to get 672. So 672 is equivalent to S14, or the series of the 14 terms. Okay. All right, so I'll leave this page here. So now the second one, what's different in the second one? We don't have the common difference. However, we do have 2 locations. We have 2 locations. What's kind of our strategy? What do we want to try? It's kind of that slope form, right? We want to do the y minus y over x minus x to kind of get that change. Remember? So we would go with, in this case, I would go 45 minus a negative 18 all over 22 minus 21. Or not 21, minus 1, thank you. Okay. Okay, so 45 minus negative 18 gives you, what's that, 63 over 21. So you get 3 is your difference. We know 3 is our difference. We know that A is negative 18. And we know in this case N, they want 22. We now have what we need to use the regular formula. Now, we just found D just for practice, but we did have a formula where we didn't have to find, right? So I was just showing you we're going to have to be flexible in how we solve for things. In this case, we really didn't need to, but I felt like I just wanted to practice. You can always find D if you need to when it comes to arithmetic. Okay, but let's use the other formula while we're at it. Okay, so we'll just use both of them just for practice. So the one we can use that doesn't have a common difference is the one on the bottom. So S of 22, so I'm looking at the one down here on the bottom of your book there on the previous page, would be N, which is 22, times A, which is negative 18, plus T of N, which is 45, all over 2. So that would be 11, 35, 22 times 27. Why did I write 11 there? S, that's just the answer. Oh, I see what I did. Sorry. This right here is 11. S of 22. I was a little dyslexic there for a second. There we go. Okay, so 11 times 27. Okay, which you're going to get 297. So that calculates out to. Now we did find D, so we can still use the other formula since we found that. So just setting it up, you'll see it's pretty similar. S of 22. Okay, so just using this guy here at the top would be 22 times 2 times negative 18 plus n minus 1, so 21 times d of 3 all over 2. Okay, and if you calculate that, you should get 297 as well. Okay. Either way will work. All right. Okay, let's keep going here on these examples, and we're going to get to one other thing with series. Okay, so find the sum of the terms of sequence 17, 12, 7, negative 38. So it's kind of the thing where the mystery is what? What's the mystery on this problem? So we can see the d, number of terms, right? We don't know what negative 38 is for a position. Okay, so we actually have to find that because we need to know n in both formulas. Okay, so we have to know n in both formulas. So we know a, we know r, or no, sorry, d, negative 5. We don't know n. So what will we use to find n? We've used it quite a bit the last couple days. Right, and we called that the general term formula. Okay, get used to that. Remember the general term from your Shobi. The general term formula, so what I'm talking about is, for those of you guys who are a little lost, okay, this guy. Because in here, we have everything except what? N. We know what T sub n is though, right? T sub n is the negative 38. So we go negative 38 equals 17 plus, we don't know n, and we know that d is negative 5. See, now we're just solving for n. Okay, so we can minus 17. So negative 55 equals a negative 5n plus 5. Subtract 5. N is 12. We expected n to be positive, so that's good. Okay, n is 12. And now we're ready to use the formula for the series, because it wants to know the series 212. Okay. All right, so if we plug it in, we're going S of 12 is 12 times 2 times 17 plus n minus 1, so 11 times the common difference of negative 5 all over 2. So that just makes us 6 there. 34 plus negative 55. And so this one, we get actually a negative number. Does anybody want to like kind of, why does that seem reasonable? Great point. Okay, so just what Rieger said, just so you guys understand, is that we finished at negative 38. In terms of symmetry, negative 38 is bigger than 17. 17 is the biggest value positive. So your negatives are outweighing. So your negatives essentially won the battle, if you'd like. Okay, so that's why you have a negative sum in this case. Okay, S of 12, negative 126. Okay, I've got one more here, and then we're going to get to the how to find terms from series. Okay, we'll be done here. All right, so this one. All right, Peter starts work at a salary of $16,000 per annum, so annum is just year. He receives annual increase of $850. He works for the firm for 12 years. Calculate his salary in the 12th year. Okay, so we know 16,000 is still going to be his T1 because that's his year 1 of working. We know that his common difference is going to be 850. Okay, and then we know that he is working for 12 years. Okay, hope Peter's not living in Calgary, right? I won't make it. So we got salary in the 12th year. Is that a series or a sequence question? Is that a series or a sequence question? Sequence. It's asking for a position. It's not asking for a sum. It's just asking how much you make year 12. So that's a term. So we're saying what is T12? So we will say that 16,000 plus 12 minus 1, so 11 times 850. So in his 12th year, he is making 23,000 or 25,350. Okay. Okay, and then it asks how much he worked, how much he made in the total 12 years. And now you see the word total. That's your S12. That's your series trigger, total. So we have all the information, so we can just plug it in. We don't have anything to adjust. We know we're going to go, okay, so it's going to be N, so 12 times 2 times A, so that's 16,000, plus N minus 1, so 11 times your D of 850 all over 2. That's what you're going to calculate. And this is just pretty much number crunching. But he will get his S12 for almost $250,000. 248,100. That's how much he's made in his 12-year career. Okay. Got some different. Check your brackets, but I can look at it. We'll pause though. I'll kind of go to the next page here, and we'll see. So series can help us get term numbers, and we'll kind of show you the pattern here, and then we'll just kind of talk about it. But they kind of overkill this little one, so just be patient, okay? What they're saying is complete the work for the following terms. They're telling you the series is represented by this function. So what happens here, it's a unique situation where this series is a very specific function, okay, in terms of how it's growing. And so what you do is, for example, series 1, if I plug 1 in for n, I get 2 times 1 squared, which is 2. 2 minus 1 is 1. Okay? If I have a series of 1, so if we just had a pattern of 4, for example, and I said that's your pattern, that's term 1, right? Well, what's S1? It's 4. Okay, so your first thing I want you to understand is term 1 equals S1 in terms of your series and your terms, which makes sense because you're not adding anything to it, right? It's just one term. Okay, in this case, for their pattern, remember this is a given pattern. You don't have to memorize this, and this is not going to be this all the time. This is a given function. Okay, so that's just people think that's like a formula. It's not. It's a given function. So in this question, when I plug 1 in, S1 is 1. Therefore, term 1 is 1. That's my point. Now if I do S2, I plug 2 in. 2 squared is 4. 4 times 2 is 8, minus 2 is 6. So S2 is 6. Okay. And we know that S2 is the same thing as series 1 plus term 2. So if I did 1 plus term 2 would be 1 plus 5 is how we get 6. Okay. But conversely, they're setting up the formula, and this is what we're going for right here. This is the point. S2 minus S1 gives you T2. So all the time, I'm just going to jump the gun just because there's a lot of subscripts going on here. What's S3 minus S2 give you in terms of terms? If I'd say S2 minus S1 gives you term 2, what's S3 minus S2 give you? Term 3, yes, term 3. Okay, so S5 minus S4 gives you term 5. Okay, the reason that is because what you're doing is if you have S5 and S4, you subtract everything off the 5 except for the term 5. So what I'm saying is, again, I'm kind of going off the grid here a little bit. If I had 6 plus 4 plus 2 plus 0, right? That's going down. So if I went ahead, actually, let's go up. Let's not go down. Sorry. I want to go up. Let's just say 2, 4, 6, 8. Okay? So if I took S4, which is all of these, and I subtracted S3, it would subtract these. So if I subtract S3, that's this. S4 is this. So what I'm saying is if I subtract this off, it leaves me with the term. That's what's happening. It's like you're cutting off the end by subtracting the previous series, okay? And so that's what we're illustrating here. And we're going to talk about some more. I just think that this is kind of harder to read. So S2 minus S1, 6 minus 1, term 2 is 5, is what we're getting to. Okay, so let's try it again here. So S3, 3 squared is 9, 9 times 2 is 18, minus 3 is 15. S3 is equivalent to S2 plus term 3. So term 3 is equivalent to S3 minus S2. So since we know S3 is 15 and S2 is 6, 15 minus 6 is term 3, so it's 9. Yep, you can see the pattern now, right? It's going up by 4. It's correct. It's arithmetic, so don't forget. And so now they want us to fill this whole thing out. So 2 times 4 squared minus 4. Erase that ugly 4 there. So 4 squared is 16, times 2 is 32, minus 4 is 28. Okay, S4 is the same thing as S3 plus term 4. So term 4 is the same thing as S4 minus S3. So that's going to be 28 minus 15, which is 13, which falls in line with our pattern of 4 again. So now this part they're trying to get you to understand the pattern. So term 2 in terms of series, well, term 10 would be S10 minus S9. That's what we're trying to accomplish right here. So if you're given series totals, you can subtract successive series to get the current term. Now it wants it with letters. T sub n is equal to S sub n minus S sub n minus 1. So see how the 10's matched? So the n's match. 1 less, n minus 1 means 1 less. Okay, finish up this investigation. Got one example and we're done, so hang in there. I know it's been a long week. All right. So the second question that Corey received was find T sub n if S sub n equals 2n squared minus n. So it wants you to find the T sub n formula using this. So that's a general form. Okay. So up there, we knew A was 1, right? And what was the common difference up there? We noticed 4. Okay, so that means we're looking at T sub n equals 1 plus n minus 1 times 4. So T sub n equals 1 plus 4n minus 4. 4n minus 3 is the pattern, correct. And this is a little bit messier. We'll do it. This is probably one of the things they're just getting you to prove that you don't necessarily need to prove, but you can just do it with me just for the heck of it. So now they want you to show it using this series. So we learned just now that T sub n equals S sub n minus S sub n minus 1. So we're just going to expand upon that. What is S sub n right now for the problem we're doing? It's right there at the top. Right. So I'm going to replace this. I'm going to put this right here. And then here, I'm going to put that, but I'm going to put what? Instead of n, it's going to be n minus 1's here. Okay? So watch. It's going to be like this. That's the first piece. That's this piece. I'm going to go minus. And n minus 1, that means the n minus 1's go for n here, okay? So it's going to be 2 times n minus 1 squared minus n minus 1. This is where it gets a little messy looking, because we're inserting n minus 1 into the n. This is strictly just for proof. This is good algebra practice of seeing how we're simplifying. Okay? So don't get overwhelmed with this, please. So the right side is what needs the most work, because we have to FOIL that stuff out. Hopefully you remember how to FOIL a little bit. So FOILing this out, remember, that would be this. N minus 1 squared is times each other. So that's going to be n squared minus 2n plus 1 if I FOIL that out. N times n, negative 1n, and negative 1n for negative 2n, positive 1 there. And we're going to hit those all with a what? 2. So here's where we're at now, okay? Minus 2 n squared minus 4n plus 2 minus n minus 1. or minus a minus 1, so plus 1. And now we're just going to combine our like terms here. You're going to see it come out pretty nicely here. So look. See this right here? 2n squared minus 2n squared. Get rid of that. We don't care about that anymore. So now we have negative n minus a negative 4n means plus 4n. Okay, and it's minusing this as well, so that's plus an n. So I'm showing you that's a negative negative and a negative negative there. What happens to the 2 and the 1? They become minus 3. So look, boom, boom. Just a voila moment of we just got the same thing. Okay, just showing you that doing the series is the same thing. Now, like I said, was that necessary? Probably not. A little mathy, kind of fun for some, kind of not care for some. But okay, so we got those to be equivalent, showing it works. All right, so let's go ahead and put one together here where it's actually going to help us get an answer. Okay, sorry if you didn't get that. I'm going too fast. You can have my notes after. Okay, for a certain arithmetic sequence, the series is s of n equals 1/2 n times 11 minus n. Determine the first 4 terms of corresponding arithmetic sequence. So what we're going to do is, or what should we do? Let me change the question. What should we do? They gave us a series formula. How can we use it to find our terms? Yeah, Jade? Right. Correct. So we're going to put, because remember, n, we're going to make s of 1, s of 2, s of 3, s of 4, right? And then once we get these totals, we're going to subtract the previous to get the terms. And just do that. Okay? So here we go. Put 1 in. So we get s of 1, 1/2 times 1 to the 11 minus 1. So that gets me 10. Half of 10 is 5. I'm going to come over here and do my terms. Term 1 is 5. We should know that. S1 equals term 1. Did I mess up there? 11 minus 1 to get the 10. Right, so this happens first. Yeah. Okay, so then we have 1/2 times 2 times 11 minus 2. So you can kind of see how this happens. So we're going to actually avoid decimals here, Rieger. So what's 1/2 of 2? 1. 11 minus 2. So this one's 9. So that means that term 2 is what, guys? This minus this. 4. So it's going down. Okay, we have a pattern going down. Okay, next one. 1/2 of 3. Whoops, not 1/3. 1/2 of 3 times 11 minus 3. So we get 11 minus 3 is 8. 8 times 3 is 24. Half of 24 is 12. 12 minus 9, 3. So this was S3 minus S2, S2 minus S1, and this was just S1. Okay, and the last one, because I wanted the first 4 terms. 1/2, 4, 11 minus 4. So half of 4 is 2. 11 minus 4 is 7. 2 times 7 for 14. And there you go. 5, 4, 3, 2. Okay, that's it for that. Amy.